It's not a trivial situation. Any questions? Any questions? Okay, moving on.
I have one question.
Yes.
So this might be a silly question, but how did we get at the end of the I don't even know what it's called, the super long one that we had before we got to 7h over
Yes.
in orange. How did we get x plus h plus 3 at the very end? Because I understand that up until
I just copied this here.
Yeah.
So 2x times these three, I have to get these three terms. -1 times -1 times these three terms, I get x plus h. I have to get 6 terms, right? So 2x multiplied by 3 terms, I get 3 terms. And 1 multiplied by 3 terms, I get now 6. If I don't have 6 terms, something is wrong.
Gotcha. You explained it great. Thank you.
Better?
Mm-hmm.
Because see here, I have 2 terms times 3 terms, I have to have 6. 2 terms times 3 terms, I have to have 6. If I don't have 12 terms, 2, 4, 6, 8, 10, 12, then something is wrong. Better?
Mm-hmm. Thank you.
Thank you. Good. So let's go back to our text. So this was really I think it's clear now. I would highly recommend you work on more examples and check the answer in the back of the book. Okay. So now, for example, I'm sure you remember the vertical line test. How do I check whether a function, a graph is a function? So for example, here, when I draw a vertical line through the graph, I realize that it crosses more than once. Each x has to have only one y. But here for x equals 1, I have 2, 4, 6, 7 different y values. So this cannot be a function. This is a function by the vertical line test. This is a function by the vertical line test. This is not a function by the vertical line test. X equals 5 or 2 or 3. This is a function by the vertical line test. This is a function by the vertical line test, and the same here. Okay, now I would like to talk about, here, for example. Is this a function? Yes, it is. Because at this point, this is a full point. The function exists there, but not here. So by the vertical line test, this is a function. The same thing here. This is not. By the vertical line test, this is not a function. Here, this one is not. Because at this point, it appears to me that they are one on top of the other. If they are, then this is not a function. Now, what I would like to talk about is a piecewise defined function and how to graph it. That's very important. I said you're always in the way. I'm kidding, of course. So let's choose a function and graph it. So choose a function, please. So let's graph it, a piecewise defined function. That's on 4. Which one? 66, you said. Okay, very good. So let me copy it and then I'll stop sharing. 2x minus 3 for x less than 1, 5 for x equals 1, and x minus 2 for greater than 1. Perfect. Okay. We are asked to graph this function, and we will have to go through the following steps. Number 1, we will have to identify the domain. Number 2, we have to create a table of ordered pairs. Table of ordered pairs. And number 3, graph. And number 4, range. Okay. Before we identify the domain, So one more time, this is called a piecewise defined function. It's defined in pieces. How many pieces does it have?
Right.
Yes, it has 3 pieces. 1, 2, 3. Perfect. So before I identify the domain, I will look at each piece and see where it is defined. Now you understand that it will be a terrible mistake to graph something like this. First of all, this is not a function by the vertical line test. The graphs cannot overlap. This is only to the left of 1. This is only when x is 1. And this is only to the right of 1. So there is no such thing. Every piece is individually, it's a function by itself, right? But it's a different, they are not overlapping. They are not, they could be linked, but not overlapping. Okay, so be careful on that. Good. So can anyone give us the interval notation for this? Forget about anything else. So my question is, how do I write the interval notation for such inequality?
Negative infinity, comma 1, and it's going to have parentheses here.
Excellent. This cannot be written as an interval. This is just the 0.1 comma 5. And what about this one? How do I write this in interval notation?
1 to
Infinity, comma 1.
No, 1 to infinity. Good.
Oh, 1 to, yes.
Correct, correct. I know what you mean. Good. So now I can identify the domain. Can anyone, by looking at this, tell us the domain of this function?
Is it all real numbers?
Awesome. Who said that?
Natalie.
Thank you. Indeed, domain is all real numbers. So now I know that I can start my table. I cannot start my table before I identify the domain. That's a must.
Can I ask a question real quick?
Yes, any question?
With piecewise functions, do our domains need to have the brackets like the equations last class did? If it's a real number, not an infinity.
It depends on whether the function is defined there or not. Very good question. So it depends. No function, not all functions are defined on all real numbers. This one is.
Mm-hmm.
But they.
So if the domain was negative infinity to 5, would the 5 be in a bracket?
It depends. Very good question.
Okay.
Very good question. So I could have a graph like this. Perfect question. So the domain of this function is 5 to infinity. Or I could have a graph like this. The domain of this one is 5 to infinity.
Okay, so it just depends if 5 is included in the domain.
Exactly. Yes? Was that the question?
Yes. That
Okay, perfect. Okay, so obviously 1 has to be in the table. 0 is always in the table, even if the function is not defined at 0. 0 has to be in the table. Now, let me take that back. So if that's like we discussed a second ago. So here, if the domain is only 5 to infinity, there is no reason to put 0 in there. But if the domain is negative infinity to 0, 0 to infinity, I have to put the 0 in there. So if it's in such a situation, I always have to have 0. And also 1. How do I handle this? How do I handle this 1? Well, I see a left parenthesis facing that way. I see that at 1 is 5 in the middle. And I see a right parenthesis facing that way. Bear with me, and I'll explain more, and you'll see what I'm doing. Between negative infinity and 1, I know this is an overkill, but sometimes these branches are not presented in the correct order, just to mess us up or to try to. So I write here on my table a note saying, careful, between negative infinity and 1, you must use 2x minus 3. Between 1 and infinity, you must use x minus 2. And this point, I already put it in. When x is 1, y is 5. Both these functions are, we already seen one today. What type of function is this? Again, anyone else? Jessica, what are these two functions? What type? Jessie, are you with us? Anyone else would like to identify these two functions? If we don't know what they are, it will be difficult to graph them. I know you know what type of functions they are.
Are they linear functions?
Of course, both are linear. Good, linear, linear. So 2 points will be enough. I'm going to plug in 0. Tell me what we get.
-3.
Great. I'm not allowed to plug in 1, but bear with me and plug in 1 in here and tell me what you get. And write it inside the parenthesis. See, this happens exactly under 1. So please do not write it like this. 1 here and then something like this. No? Is that clear? So these have to be exactly under 1. Right. Sorry.
It would be -1.
Very good. Awesome. Now plug in 1 on the other side, please.
-1.
Good. Inside the parenthesis. And let's plug in 2 because something very important happens at 2. What do we get?
0.
Excellent. Well done. Okay, so let's do this together from left to right. Can anyone give us the first ordered pair that we need to plot? I'm going to use 3 colors. Green, red, and blue, because there are 3 different pieces. So you understand that they cannot overlap. Okay, green, what is the first ordered pair I have to plot?
0, -3.
0, -3. Is it a full point?
Yes.
Of course, very good, awesome. 1, -1, that's the next ordered pair. Is this a full point or not?
No.
No. Can anyone explain why this is not a full point?
Not included.
Because of the parenthesis. I cannot even plug in 1 in that branch. Okay, next color. The second branch. What do I have to plot?
1, -1 again.
I'm not there yet.
1, 5.
Excellent. Full point or open point?
Full point.
Excellent. That's the point. It has to be there. I'm done with the second color, which is the second branch. Now I move on to blue. Next ordered pair.
2, 0.
I'm not there yet. I'm here.
-1.
I'm here. Yes. 1, -1. Still open. And then you said 2, 0. Perfect. Excellent. You understand you cannot extend the green, you cannot extend the blue, and you cannot do anything with the red. Finally, I'd like to identify the range. What is the range of this function? Remember the range? We start from negative infinity, and we imagine we cut this graph with horizontal lines. So what will you say the range would be?
-3, 5. Be negative infinity to 5, right?
Negative infinity to, whoops.
0.
It's a hole in here, right?
-1.
Yes, negative infinity to -1 union.
-1 to infinity.
That's it. Well done. Good job. That's how we graph a piecewise defined function. You do not have to use 3 colors. The reason I use 3 colors is to make you understand that you cannot extend the green and you cannot extend the blue. This will not be a function anymore. Every function has, or sub-function if you want, has its own graph, not overlapping with anything else. Okay. Okay, I would like to look at some word problems and move on. Let's see what if there is anything interesting in here. Okay, let's choose one and let's move on to R.3. Okay, so let's see. Maybe compound interest. We looked at this before. We already used this with the graph calculator and everything. If you want, we can do one. This is a sad one with chemotherapy. We can do that. You want to look at chemotherapy?
Let's do the chemotherapy one. That equation looks interesting.
Okay, very good. Perfect pick. So I'm on page 5. So let me start the